everyone, it's Judy Warner. Welcome back to this week's Ecosystem Podcast. Today, I'm joined by Kyle Stone, the Product Marketing Manager at Texas Instruments. We're going to talk all about sensors today, and he has some really interesting information to tell us about sensors, the applications, what innovations are going on in the industry, and give you ideas about what the trade-offs might be between using discrete sensors versus on-chip sensors. I think you're going to enjoy this one and have some great takeaways. Now let's jump into our conversation with Kyle Stone. Hi, Kyle. Thanks so much for joining us today on the podcast. I'm very interested to talk to you and all your knowledge about sensors today.
Thanks, Judy. Super excited to be here and, to give my knowledge to you and to your listeners. Thanks.
Well, let's jump in by giving a brief overview of who you are, what your background and interest is, how you became a sort of a sensor geek, and what you do for Texas Instruments.
Sure. So I graduated from the University of Florida with my electrical engineering degree back in 2019, so pre-COVID times. And I then joined Texas Instruments as a product marketing engineer on the current sensing team. So that's where I got my feet wet with sensors in general. They have a lot of various sensors within the sensing org there. And from there, I've since moved to the precision ADC group, where now we're converting the signals that some of those sensors would be outputting. So that way, maybe a microprocessor could potentially, do some calibration or reaction to those sensors.
Interesting. Well, I can't wait to jump into the subject and learn from you and sort of get the pulse of what's going on across the industry. So why don't you give us a sense of just, as you made that transition from sort of a generalist to maybe a little bit more niche, like how many sensors are there out there? I would expect a lot, but can you just give us an idea of the overview of the sensor market and maybe some of the applications that are kind of prolific these days?
Sure. So there's a ton of different sensors. We can start kind of maybe with the more basic ones. So as you can imagine, there would be temperature sensors, the temperature in various systems. They could be just, very small temperature sensors, what we may call like an NTC, all the way through like a semiconductor-based temperature sensor to RTDs, which we would find in factories. Also thermocouples as well, which we may find in factories. So temperature may be the easiest one for most people to grasp. Beyond that, then there's humidity sensors, which would be sensing humidity in various locations. There's gas sensors. So if you're, say, like in a mine or something like this, or, needing to sense like carbon dioxide or something along those lines, then gas sensors could be important. There's also pressure sensors. So in a lot of, say, factories, there's a lot of pipes that are flowing with different fluids or, just different mediums. And you need to sense the pressure in those to, determine maybe if there's a critical failure or if there's too much pressure, too little pressure, et cetera. So that could definitely be like a safety mechanism, if you will. And then beyond that, there's current sensors. So as an electrical engineer, we learn about Ohm's law, V equals IR. Current sensing is very important for essentially all systems. And then also voltage sensing, right? So voltage and current together will make you power. So power sensing. So there really is a wide variety of sensor applications, and really any sort of system per se could use various sensors to make sure that it's, running optimally and it's in a good, healthy state. And there's no issues maybe outside of the immediate system, but like say on a factory floor or something like this.
I assume my first thought goes to, of course, electrical vehicles and things like that. Where do you put that in category wise?
Electrical vehicles have, so there's a lot of different sensors in electrical vehicles. So maybe we just start with the batteries first off. So in the batteries, you have voltage and current. So you're going to want to monitor those. So that's a first pass. And then from there, still within the batteries, though, you may want to monitor the pressure within the battery cells, because as you charge a battery, it's going to increase in temperature, and it is a sealed component, so it will theoretically increase in pressure based on the various chemistry principles. And then from there, going from the battery maybe to the electric motor itself, you'll want to sense the current going into the motor to make sure that you're controlling the motor correctly. You also want to sense the voltage for the same reason, but also temperature as well, because you are, dissipating a lot of power across that motor. So making sure that the motor is running optimally and you're not pushing it too hard. And, if you are pushing it too hard, maybe the current sensor would, say, hey, we need to limit this a little bit, and would feed that back to the microprocessor or the controller in the system. And then, maybe we move a little bit outside the mechanics of it and we go into the cabin of the car. So we all have AC in our car for the most part. So there's going to be some sort of sensor in there to sense, what the temperature of the AC is. And if you put it on like an auto setting or something like this, make sure that you're getting the proper AC flow, for instance. Some of the other sensors that could be in there, though, too, are say position sensors. There's a lot of different things that are moving inside of a car, such as a window, maybe like a gear shifter or a windshield wiper or turn signal. So making sure that, the sensor is sensing what location those various things are in for A, to take some sort of command, or B, maybe for a safety thing. Say you have a small child, for instance, that puts their hand in the window and the window's going up, and you want some sort of sensor there to make sure you don't hurt anyone, essentially, right? So really, there's sensors throughout the entire automobile, specifically EV cars, because they are driven by electronics. So very important.
Well, I think that's kind of a good picture that sort of illustrates that if we could sort of have X-ray vision and see how many sensors are around us every day, they must be all over in our homes, in our cars, and everything we do. So, well, that's an interesting way to look at it, I think. So since we're talking to a professional electronic engineering audience here, from your perspective and interacting with your customers, what kind of implementation challenges are you seeing sort of across the industry because of all these complexities and the proliferation of sensors all around us?
Implementation challenges, there could be a number. Potentially interface implementation options could be limited as we continue to move down this, because it really is a new area. So making sure that the sensors are, being able to interface with the various controllers, and making sure that you have the proper sensors that can deal with the different, say, temperatures or pressures and different things like this within the system. So just making sure that as the technology evolves, that the sensors are evolving even faster, essentially, to be able to embrace and enable that new technology. The industry is definitely moving in that direction quite rapidly. So they are overcoming the challenges quite quickly.
So for our audience, are there specific strategies you might recommend that they employ as things speed up and, sort of with the current state of sensor technology? Is there any blind spots they might have, or maybe repeated questions you get from engineers that are implementing these technologies?
There are some questions that come up, pretty commonly. We typically see them maybe in some of the newer like startup companies that we help support, essentially. But Texas Instruments does a great job with maybe providing what we call reference designs to help get you started. Reference design is essentially just like a basic circuit diagram that has been tested and validated to make sure it works. So, leveraging some of those would really give you a jump start on your design potentially, and it could also, give you the latest and greatest as well. So that would be, maybe one of the recommendations that I would give to your audience, especially if you're in a new startup phase and maybe you don't have all of, the engineering and all this sort of stuff in place. A lot of the resources, could be found out there, and, we are on the cutting edge of this. So we try to put our best foot forward for everyone and give the most relevant information.
Good. Well, remind me, Kyle, and I'll grab some of that information with you, and we'll send our listeners that way to grab some of those resources. So I know that you taught me something interesting as we were getting to know each other and we were talking about sensors, is that the sensors can live right, inside the chip or as a discrete device. So can you talk about the trade-offs and the strategy around when do you use what, and how do you help engineers navigate and answer those questions?
Sure. So I'll start with maybe the discrete approach, just because maybe it's a little easier. It's kind of like a Lego system, if you will.
Uh-huh.
Yeah. So typically with a discrete approach, there may be some sensor out there. I'll use a RTD sensor, which is a temperature sensor for factories, typically speaking.
Mhm.
Typically, the RTD sensor is out in the factory, and then from there may be an ADC that is attached to that RTD or kind of within that system. And the RTD needs to have certain things like excitation currents and whatnot in order to properly work, essentially. So having it as a discrete it enables it to be more accurate, essentially, because you're able to fine tune exactly what's going on there. So that would be maybe like a discrete example where you really need super high accuracy. So you have your, two, maybe three components, you put them together, you calibrate it, you fine tune it, and you put it out on the factory floor and it works exactly as expected. And then, if we were to move to more of like an integrated approach, then you take some of that customization out of the actual sensing technology, right? So you're not able to maybe choose what amplifier you want in it or, what type of range of a sensor you want. That stuff is already bound, essentially.
Right.
But as a result, it should be optimized, at least for that particular range. But if you're maybe outside of the range, then you would need to, maybe do a discrete approach. So it kind of just depends on what the folk is looking to do, essentially, and how optimized they want their system or how compact they may want it. So there's a couple different variables there that could lead you to go maybe discrete or integrated.
Now, what about multi-channel considerations on chip level versus discrete?
So multi-channel can be something, it really depends on how many things are going on in the system. But even though you have like a multi-channel converter, you may only be still monitoring just one sensor potentially, because you may be monitoring a sensor in various locations, and you'll take those various measurements that you get from the converter, say, and then maybe do some sort of averaging or some sort of analysis on those in order to actually get the result. So, from that perspective, it depends, right? And that's maybe one example. And another example is, hey, I've got 10 current sensors over here, and I've got 5 voltage sensors over here, and a couple temperature sensors, and I need to put them all into one and then feed it into my controller. That could be another example where you have those individual components, maybe sprinkled throughout the board versus maybe just one component that you need like super high accuracy. So you would take multiple measurements of it. So when you look at multi-channel, you have to unpack it a little bit depending on, exactly what the system is looking to do.
Right. When you keep saying it depends, I always smile because Eric Bogatin, when he talks about signal integrity, it's like, is it this or this? And the answer is always, it depends, which is pretty much the story of electronics design, right? It always depends on what you're trying to do and what the application is. So I know I'm asking you sort of a little bit of softball questions, but I want our listeners to get a sense of, when to look at this one and when to look at this one. And you're saying to me that TI is kind of running ahead of this in this area and providing some innovative solutions that makes it easier for engineers. So I'm just trying to unpack for our listeners when to use this, when to use this. So why don't you talk about the specific ways TI is kind of innovating in this area as you've looked at these complexities and these challenges, and where we are today and when you might see us going in the next 5 years or so.
Sure. So I will go back to the it depends comment. So I believe a lot of your viewers are engineers, and this is probably one of our favorite words in our vocabulary.
Yes.
So
yes,
it's a pretty typical thing, just because we're so analytical. But anyway, where we're headed, where we're headed in general is going to be, higher sensitivity, higher voltage, higher temperature ranges, more compact, more integration, smaller size, lower cost, all those sort of things, we're driving towards ultimately, because we do believe that the world will be proliferated with sensors in the future, because there'll be so many different things that just need to be sensed. And there's so many different things that are around the environment today that are being sensed that most people don't actually realize that they're being sensed.
Right.
The reality of it is this podcast that we're on right now, there's probably, hundreds of sensors that are working in the background to make this work. Just the cameras alone here, right? So,
right.
And, if you think of a digital camera versus like a film camera many years ago, that alone is a huge feat. And now we have, phones that are essentially. So, but yeah, generally where we're headed is higher integration, which could make it easier for a customer to design. But we also will still offer those discrete components. But if you want maybe like an off-the-shelf approach, you could just use a highly integrated device that would enable you to do those sort of things. And really over the next, 5, 10, 15, 20 years, for instance, I can see that we continue down that path, just higher level of integration, more accurate. So that way you can sense those sensors more accurately, more redundancy built into the sensors. So adding something what we call functional safety. So that means, making sure that the converter or the sensor, whatever you're, looking at, is actually giving you proper results, essentially making sure that it's properly connected and the voltage ranges are within spec and all these sort of things. So having some of that into the sensor will make a more safe system ultimately. And that's something that we're seeing as a trend, actually. Folks are requesting these functional safety things more often, where this used to be maybe a little bit more limited to like an automotive approach, where you're driving a car and it's kind of dangerous. But now we're seeing, more requests in other areas for this functional safety to ensure that, say robots are functioning safely and different things like that.
Or manufacturing lines or right, or jets or whatever it is, right? So, well, this has been really interesting learning about an area where I've known just a little bit about, and I hope our audience has learned something from you as well. I will get with you, Kyle, and see if I can grab a few resources, downloads, or learning pages anywhere you have some resources. I'd be glad to share that with our audience so they can dig in a bit more. But last question is, I know you just came from Taiwan and you saw, 10 or so customers. Sounds like a whirlwind tour. Are you noticing any trends globally, or do you think this is just a global phenomenon where these technologies are proliferating? Do you see any differences as you're out traveling globally and talking to customers?
Generally what the customer is looking for is, having those levels of integration. They're putting more sensors on the boards, for instance, servers, data centers, things like that. They're moving towards like a liquid cooling system. Historically, they've been air cooled. Yep. So liquid cooling requires additional sensors, such as some of the sensors that we talked about here, like pressure and flow sensors and things like that. So they're looking for, these various sensors, which maybe had been siloed in like an industrial setting, but now they're starting to proliferate, outside of those industrial settings into some of the other areas that we focus on here at TI.
So interesting. Well, I'm sure you see so much. And one of the interesting things I've seen in regards to data centers is I was asking some, very advanced engineering experts about certain technologies. I'm like, what's driving that? And they're like, TikTok. And it's like streaming video and data centers, right? Besides AI and machine learning, ChatGPT, all these things, which just, it makes me laugh because it's like, boy, I didn't see that one coming. But, it's just all the streaming data and just the data demands are driving so much of this. So very interesting. Well, Kyle, I'll let you go. Thank you so much for your time. And I'll get with you on those resources for our listeners. I'll get some resources from Kyle and I'll make sure that I'll put them for you below in the show notes. And again, Kyle, thanks for joining. And I hope to see you before long at a trade show.
Thanks, Judy. It was great talking with you today.
You too. For our listeners, thanks so much for joining us today. We will see you next week. Until then, remember to always stay connected to the ecosystem.